All right, so let's look at this example. 12 cars were equipped with radial tires and driven over a test course. Then the same 12 cars with the same drivers were equipped with regular belted tires and driven over the same course. After each run, the car's gas economy in kilometers per liter, that's kind of like miles per gallon, was measured. Find a 95% confidence interval for the mean difference in gas economy between the radial and the belted tires. Right, so we know that we have some sort of paired data here because they talk about these 12 cars, they have the same drivers, and what they're saying is, well, first we put the radial tires on them and we ran the course, and then we put the belted tires on them and ran the course. So this is telling me that I have some paired data here, so that is a good thing. And what I'm looking for is a 95% CI for the mean difference. Gas economy. And I'm just going to put radial versus belted. All right, so that'll give me an idea of what I need to do in my write-up. We talked about it being paired already, but it doesn't mention anything about a random sample. So I'm going to put a little star here and put not stated. I do have that paired piece, which is good. My sample size is the 12 cars, so definitely not large enough. So I need to go and look at that normal probability plot. And I'm also going to need to go look at that data set so I can get the standard deviation from the differences. Okay, but once I've done those things, then what I have here is a paired t-interval. And while I am there, I'm also going to get d bar, so that's the average of my differences, so that I can put this into the Excel calculator and get my interval out. So let's switch over to the data set so we can work on some of that. All right, so here's our data set. And the first thing I need to do is actually get these differences. I have a column with my radial values, and I have a column with the values for the belted tires. So there's the fuel efficiency there. So I think I'm just going to do radial minus belted. So in this box that says difference, I'm going to put in equals, and then I'll click on this radial. I'll put a minus sign, and I'll click on the belted. And then I'm going to push enter. So it subtracted those two for us. And then I wanted to do that for every pair. So I can copy and paste that going down. And so there's my differences column. And that's the column that I'm interested in doing all of my work for with this. So I'm going to start by making sure that I have a normal looking data set here. So I'll go over to data and I'll go to data analysis. And then remember that our normal probability plot is held under the regression. So we'll pick regression here. My Y range is the differences column. So I'm going to highlight these differences. And then it doesn't matter what I put in for the X one as long as it's one of the other two columns. And then I'll click this box that says normal probability plot. I actually just want to put it on this page. So I'm going to click here. And there's my normal probability plot right there. So if I kind of line up that top dot with this bottom dot, I'm going to get a little overage down here and a little underage here. So it's not the greatest, but it's not terrible either. So what I'm going to do on my paper is I'm going to circle the word normal, and I'll put a little note that says the NPP is a little bumpy. It's not bad, but it's also not fantastic either. And then the other condition I needed to get my standard deviation here. So let me do that. Equals STDEV. And I'm going to highlight only the numbers in the differences column. So I get 0.2 for that. And I need the average for these as well. So equals the average. And that'll be my D bar. So highlight all those differences. And I get about 0.1 here. Actually, I'm a little bit concerned about this guy. So let me see if there aren't more decimal places there, because I feel like there probably are. There we go. So I'm going to modify this a little bit so I have a little bit better accuracy. So instead of writing my standard deviation as 0.2, I'm going to go 0.1975. So if you use 0.2, you'll get a slightly different interval than me, but that's totally fine. So we have everything we need and we're ready to put this into the Excel calculator. So I'm going to switch over to that. All right, so I want to make sure that I'm on the T confidence interval for chapter 20. And I'm going to enter these numbers that I got from my paired column. So first of all, my confidence level is 95%, so I'll leave that. D bar, so those are my differences, that was 0.1. SD, which is my standard deviation of my differences, was 0.1975. And then my sample size was 12. Okay. So I have a lower bound of my interval is going to be negative 0.03. And the upper bound is 0.23. I'll just round up there. All right, and so we're ready to come back and look at our conclusion here. All right, so here are those numbers that we got. I filled in kind of the rest of these things. So my conclusion here is we are 95% confident. The mean difference in gas economy between radial and belted tires is somewhere between negative 0.03 and 0.23 kilometers per liter. Okay, put those units on there. All right, so we have this, and I want to talk about actually what this interval means, because it means actually a little bit different than what it did with our 1 mean z and 1 mean t interval. So you notice that this interval has a negative number to a positive number. So what we're really interested in is if the number 0 is in our interval. If the number 0 is in our interval, what it means is there could actually be no difference between these two types of tires, okay, or whatever two things you're comparing. If 0 is in the interval, it might mean that these two things are basically about the same. Okay. If 0 is not in the interval, then you have conclusive evidence, at least to this confidence level, that there is a difference and one of these is better or does something more than the other one does.